Okay, trig identity proofs. Okay, so sometimes the best way to attack this is to have a left-hand side and a right-hand side. And try and get the left-hand side to look the same as the right-hand side. So I'm just going left-hand side, right-hand side, and I'm going to put a line down the middle. So if I start working on the left-hand side here, sec theta, if I go to the third letter, that's 1 on cos. Tan theta is sine theta on cos theta. So when we're looking at that then, that just has a common denominator of cos theta. So on top we just have 1 plus sine theta. And that just equals the right-hand side. So it's proof. Okay, so if we look at this one here, all right, we go left-hand side. So the left-hand side, all right, so expanding this, you get 1 squared's 1, minus 2 times 1 times tan x, plus, square the last one, tan squared, plus 1 plus 2 times 1 times tan x, because 2 times that, a times b, plus the last one, which is tan squared. So the 1 plus 1, that will be 2. And the tan squared plus tan squared, that'll be 2 tan squared. These here are the same, so they'll cancel out. Okay, so get 2 plus 2 tan squared theta. So if you take a common factor out, that's 1 plus tan squared theta. And 1 plus tan squared theta is just sec squared theta. And that equals the right-hand side. So that is proven. Okay, so now let's just look at the left-hand side, right-hand side here. So on the left-hand side, we have cot theta. I'm going to change that to cos on sine. So remember the C's go together, CC. 2 on third letter's cos, so it'll be cos theta. Okay, now we might want to find a common denominator because we have 2 separate fractions here. So if we times this one by cos theta and this one by sine theta, then the denominator will be sine theta cos theta, and the top would be cos squared theta and 2 sine theta. Now, I kind of don't think I can go any further with this, so I'm going to look at the right-hand side. So when I look at the right-hand side, I straight away see 1 minus cos squared. That's 1 minus sine squared. That's equal to cos squared. Cos squared 2 sine theta. And what's that over? So that is over sine theta cos theta. And if I look at my left-hand side, that is now the same as my left-hand side. So that equals to the left-hand side proven. Okay, so let's just look at this one here for number 4. Right, we've got all sorts of things happening. There's not a lot we can do on the right-hand side because it's just cos theta. So on the left-hand side, let's have a look what we can actually do here. All right, so that is 1 plus. I'm going to change the cot to cos theta on sine theta. I might just go the method of changing everything to cos theta on sine theta. And that's 1 on sine theta. Cosec, is the third letter is cos. So that's 1 on cos theta on sine theta on cos theta plus cos theta on sine theta. Okay, now to actually simplify that, one of the best things you could do is to times the top and the bottom by sine theta. Because when you do that, that will cancel the denominator. And this one here, the common denominator would be sine theta cos theta. So if I do the same thing here, times that by sine theta cos theta, then on the top here, we end up with sine theta plus the 2 sine thetas cancel out and you get cos theta. And on the bottom, the sine goes and you get 1. When we're doing this one here, these are on top, so the coses will go out and you're just left with sine theta. And on the bottom, the first one, the cos will go out with the cos and you're left with sine squared theta. And on the top, the sine will go out with sine and you're left with cos squared theta. So you get sine theta plus cos theta on 1, which is just sine squared theta plus cos theta. Sine theta, now sine squared theta plus cos squared theta, this one here, that is just equal to 1. So we have sine theta plus cos theta minus sine theta. The sine thetas go out and we're just left with cos theta, which actually equals the right-hand side, okay? If you don't like the method of multiplying the top and the bottom by the highest common denominator, we could also look at this by just going like that's 1 plus cos theta on sine theta, and you divide it by 1 on sine theta. So you can do that part by doing that. Then you get the common denominator, because that's over 1. So that's times sine theta there. So it's sine theta plus cos theta on sine theta. And then you multiply by the reciprocal, which is sine on 1. So that section just simplifies to sine theta plus cos theta, which if you look back to what we actually just did, that's what we got here, okay? And if you take the other section and you do the same thing, so you go sec theta on tan theta plus cot theta, and you make the sec theta 1 on cos theta, and you divide that by sine theta on cos theta plus cos theta on sine theta, and then you just get a common denominator and you flip this. So it's 1 on cos theta divided by sine squared theta plus cos squared theta on sine theta cos theta. So sine squared theta plus cos squared theta is just 1. So that's 1 on cos theta divided by 1 on sine theta cos theta. And then you can just flip that because it's a fraction. So you got cos theta times sine theta cos theta. And the coses go out and you're just left with sine theta. Okay, so that means that you then have sine theta plus cos theta minus sine theta. And the sine theta will cancel out and you're just left with cos theta, which is the right-hand side. So you could also like simplify this just using fractions, doing them both separately, and then you multiply by the reciprocal. And the same thing happened here. You do the fraction thing and multiply by the reciprocal and you'll get the same answer as well.